Hello, good evening, ladies and gentlemen. This is Professor Khan, and this is EST-205 Advanced Heat System Design. And this is week 6, where we will discuss components of hydronic system, uh, heating system. And what does that mean? Well, we'll choose the radiators that will dispense heat inside the room. Um I will try to keep the videos brief, and please pay attention to these things because it will involve some critical calculations that you will need for your project. And I will try to quiz you on these items because they're really essential to calculate things. And instead of us doing a lot of general rules or like eyeballing things, it's good to have an idea of how these things calculated. Okay, let's start. And I have my camera here on a pad so I can uh, do some drawing as I go along. So we will do first heating unit for each design, for each room. So that could be a radiator, that could be a baseboard. I mean, baseboard is the same thing as radiator. Baseboard, radiant floor heating, or we can do panels as well, or kickboard. Kickboard are very common. Those are the ones actually that comes under the cabinets inside the kitchen. Then we will decide on the location of the boiler. Where should we put the boiler? And probably you'll see once you lay out the piping for the system that the location of the boiler can be very strategic to reduce the amount of heat distribution. I mean, to optimize the amount of heat distribution inside the house. So usually you want to put it in a centralized location, but that's not always ideal. But there are also some codes involved in that. Uh, Three, we will do designing the number of loops for the house. And we said the more zones we have is better because that means we have different optimization for what gets more heat or less heat. And the more zones you have, the more control you have over the the heat and the more energy you will uh, optimize so you can reduce your overall energy bill. Pick the right tubing and piping for the entire house size. We'll see why do we need to pick the right tubes and not just always go by the size, the same size, and why does it matter? And if we are talking about water circulation, it's kind of similar to electrical circulation, electrical circuit, and we know that large pipes have less pressure. So same thing with current and resistance. Larger wires, larger gauge wires will have less resistance. So it will all add up to maintain pressure, which is the voltage, which was the same thing that we were trying to do in electrical circuits. So we want to maintain the pressure and also supply all the resistance, which in this case will be electrical uh, radiators. I mean, baseboard radiators. Okay. We will determine also the pump requirement. That probably will be next week. What do we require for pump as a GPM, and how do we calculate the pump size? Then finally, signs the expansion tank and pick the system controls, which is something probably you have worked out a lot in combustion control circuit and also in energy system lab too. But we will address what we need for this system. And again, this week and next week will be mostly hydronic hot water system. And I say hot water system because hydronic could be also steam, depending on which industry you talk about. Okay, so selecting the heating unit for each room. It depends on the water temperature that you are planning to provide for that room and the amount of heat coming from the radiator. Also the length of the radiator. I have with me here, I'm going to increase the camera. Let me just finish all this. Uh, okay, I did that, so I'm gonna, okay, so now you can see the camera. And if you look here, I have with me, I brought, sorry about the noise. This is a baseboard radiator. These things are sold per foot. This is almost a foot here. I think it's around that. And if you look at this baseboard radiator, it's approved by the IPR. And you look, it says hot water perimeter baseboard radiator, which means it will go around the room. And this one says here, this is the information we need to actually register. 590 BTUs per 1 80 degrees. That's the temperature of the water that you would like to have circulating in these tubes. So 180, and based on that, it will give you 590 BTUs per hour. So this is going to be the radiation, and that's actually per foot. So this is almost a foot. So this is going to be, I'll say it's more than a foot, but for this piece, it's going to be 590 per hour. So I'm going to put this aside here and have you think about that a little bit, and I will change my camera again to the way it was. So now thinking about the amount of heat coming from the radiator, that's what we just discussed. The length is what we actually have to decide on. So how many feet of this radiator do we need? And we have options. We have double deckers. So we have radiators that will have two tubes, more tubes, thicker. Some of them give more heat than others. Some of them have those plates, some of them don't. So there are many options of these radiators. Okay, so if you look at in your book, you'll find this table here, which gives you some of the most common baseboard radiators available in the field. So the one we just looked at, it's type A, and that's the 3/4 tube. The tube size is the size we see over here. That is the tube size. This is 3/4, which is type A, and type B here is 1/2 inch, which is smaller. And you can tell that it has different temperature. The one we just picked up is at 180, as we saw before. This is the one. It's 180. I'm gonna have to use my marker here. So it's 180 and it's type E 3/8. And look at the flow rate that goes through it. This is very important. I'll give you a second to look at this table. Look at it. So you see type A and type B based on the the tube diameter. Then you have the flow rate, which is 1 gallon per minute. GPM is gallon per minute. That's one. And we have here 4. So the faster, the more you will get out of that, and we would like to keep that GPM. I don't know if you can see this. GPM is gallon per minute, and you want to keep that between those two. If you go a little bit faster, probably you are losing energy and you're not giving off a lot of heat. If you go slower than 1 gallon per minute, it's not very productive. So you want to have this, the optimum speed or velocity of water that you want to have. And this information we will need at some point, which is the pressure drop. This is very important because it's based on the friction of the pipe, and it will tell you how much pumping power you need to have. But for a time being, let's just focus on this is the water temperature. I'm trying to find what baseboard radiator do I need for a room. And let's assume that our velocity is around 4. So it's going to be 580 BTUs per hour. So BTU per linear foot at 65 degrees room temperature. So if the room is 65 and the water is 180, is how much BTU I'm going to give off. And just to give you some kind of physics behind what's happening. So remember my favorite equation. I'm gonna go a little bit bigger here. Remember my favorite equation, Q equal A times U times delta T. So in this case, my heat transfer from this pipe over here, I'm sure you can see it, is going to be, this is the heat coming out of this pipe here. And what is the area of this pipe? So the area of this pipe is the area of this tube over here plus the area of each one of those squares. So this is going to be the area for that tube and those little squares because they are connected with each other. This is going to be my area over here, this and this, and times U, which is the material, aluminum and copper, which are the best conductive material. So that's the material U over here, aluminum plus copper. And delta T here is going to be the temperature difference between the water inside and the room. So that's going to be 180 minus 65. And if you see that the size of the tube matter, because if you have 3/4 tube plus comparing to 1/2 inch tube, you'll have more area here than area here because of the size of the pipe. And the area of this cylinder here is going to be the circumference multiplied by the length over here. So this is the diameter here. So it's going to be the circumference, which is 2 pi r. So that's the circumference over here, and r is d over 2. So pi d, pi is a number, of course, pi d times the length. That's going to be my circumference. Okay, I hope I did not confuse you so much. And good thing about the videos, you can rewind and look at it again. So this is here. How do we take this radiator? Let's do an example and see how does this work. How do I use this table? Okay, so example one, a room that requires 5,000 BTU feet. And again, I would like to bring your attention to if you look in the camera, to this table, and then the last page of your book, there's a lot of formulas here that give you all these calculations. So, and also probably you'll have this table in chapter 6 at page, which page in the book? Let's see, page 84 in the book. So I'm going to keep that next to me, and maybe you can open the book and look at it. So a room that requires 5,000 BTUs of heat, if we were to install type A, that's the 3/4 over here. So that's 3/4 inch pipe. Radiator at 1 GPM, so it's at the slow pace, and the water temperature is 180. How many feet of that radiator is to be installed? So I'll give you a second to look at it while I jot it down. So if I look, so this is my room, 5,000 BTU per hour. And if I look at this radiator over here, so it says that the radiator is type A, which you can find at the top here, and it's 1 GPM, so it's the top point. Let me make the camera bigger so it will. So it's type A, and it's 1 GPM, and the water temperature is 180. So I'm gonna get 550 here. So hopefully you can see that in your table. So having said that, let's go back now and do the calculation. Okay, here you go. So I got 550 from the table. I showed you where we got that from. And you divide the amount of heat you want for the room by the 550, and you get 9 feet of radiator. So you're going to go and buy 9 feet of this radiator and put it somehow in that perimeter of that room. Okay, if that didn't make sense, you can rewind and look at it. But I will move on to the new topic. This is how we picked it up. Another example. Good, I have 2 examples now. So a room would require a heating load of 7,000 times 7,000, and to be heated with type B radiator, that's the 1/2 inch radiator. Water temperature is 200, and the flow rate is 2 GPM. So it's in between. It's not 1, it's not 4, it's in the middle. So we're going to go around something in between. And how do we do that? Let me use my camera. Make my camera bigger. So if you look at this here, you will see that it's type B. It's 2, so it's in the middle, and the temperature here is 180. So it's gonna be between 550 and 580. So I'll go with 560, 570. It's not going to be a big deal. Okay. So this is the calculation over here. So I guess with 680, I went with the upper limit, and I got 10.29 feet, which is gonna be 10.5 foot. Another example here, a large room, this time 12,000 BTUs, type B radiator, 5 GPM. It's a little bit above the limit, more flow. So you're gonna go with the upper limit at 4, and the temperature is 210, which is the really hot temperature. And this time I'm asking for the pressure drop. And so if you, hold on. Sorry, my video got cut off. So in this example here, we are looking at pressure drop. So that's how we use the other information in the book. If you look closely here at the book, there's also the pressure drop in milli-inch per foot. So look at it closer in your book, probably it will be clearer. And also it's in the previous presentation. And we went with 5, so it's going to be somewhere around here. So I'll go with the nearest thing, which is 2,880 milliinch per foot of pressure drop. And the pressure this time is given by foot of water. This information is very needed when you calculate the pressure for the pump. So I'll go back to the example here, and if I go on, this is going to be I took 780 because I looked at the okay, type B, and radius 5 GPM, and temperature is 210, so it's here, so it's going to be 780. I went with the higher limit, and that's how much foot of water I did need. Actually, this is the radiator. It's going to be the radiator length is 15.38 foot. That's the radiator. Then I'm going to use 2,880 millinch per foot. So work over it a little bit and let me know if it makes sense to you. This is the conversion, and now I lost in that radiator 3.72 feet of water. That's a pressure measurement. It's called feet, and that's how we need that for calculating the pump head. Okay, some tips. Usually base bed radiators are installed around the walls, preferably around the windows, because this is where you lose most of the heat. Many types of radiators, such as king tubes, radiators, and convectors, they depend on the space heat requirement and available space. Try to plan the location properly. It's not going to be behind a couch or behind a closet, because then the distribution of air is going to be reduced. Okay, I will pause now and I will do radiant floor heating in the next video.